Hi, welcome to our next lesson of Unit 1. Before we go to our next lesson, we're going to do a recap of Lesson 1.2, line segments. We learned about the difference between line and line segments. So what is the difference between line and line segment? There might be various answers based on how you would answer it. So possible answers are lines are continuous and line segments have two endpoints. Or you could have said lines extend on forever and line segments can be measured. But you know that the two difference between them is that line goes on and on and on and on. Segments stop at a certain point, start and then stop and can be measured. When it comes to writing notations or symbols for line segments in line, with a line segment, you know line, segment, it stops, you would have just a line above the AB or whatever letters you have. With a line, you just add the two arrowheads on both sides to represent line. So remember, you got to be precise because if you put one for the other, it could cause confusion. We also learned about the segment addition postulate. You've got a segment, you put them together, and then you get a whole segment. So then for this one, you got segment AB plus segment AB plus segment BC equals segment AC. If you have two given segments, in order to find the total, you would add them. If you are given one statement, a piece of the segment, and then the total length of that whole segment, then you need to subtract to get that other piece. So below we have an example using the subtraction, segment addition postulate, SAP. So I'm going to move this, and they want us to find X and FE. So get that. So we know that this is based on SAP, segment addition postulate. So we have GF, segment GF, plus segment FE will equal segment GE. So we have the first one, which is 7x minus 2, and then the other one is 5x minus 1, and GE is 21. So you solve for x. Combine your like terms, and you add 3 on both sides. You get 24, and then you divide 12 on both sides. And then you get x equals 2. But we're not done, because they also asked us to find FE, segment FE. So segment FE is equal to 5x minus 1. We already found x, so we plug it in. And then we solve. So this will come out to 10 minus 1, and then FE is equal to 9. Oops. And unveil the answer, and that's what we get. All right. So before we start our lesson, I'm going to show you something on YouTube dealing with dimensions.
Hi, let's learn about dimensions. In geometry, we can have different dimensions. Let us start with a point. A point has no dimensions. Can't see it? Well, it has no size, so let's highlight it. Now let's allow the point to move in one direction. We get a line. We need just one value to find a point on that line, so we have one dimension. A line is one-dimensional. Now let's allow the point to move in a different direction, and we get a plane. We need two values to find a point on that plane, so we have two dimensions, or 2D. Circles, triangles, squares, and more are plane shapes. Now we let that point move in another completely different direction, and we have three dimensions. Spheres, cubes, cylinders, and more are three-dimensional, or 3D. The world we live in is 3D. We also call them solid shapes. In mathematics, we can have more dimensions, but they're hard to draw. Summary. The number of dimensions is how many values are needed to locate points on a shape. To put your new knowledge into practice, try the your turn questions.
All right. So based on the video that we saw, learned about dimensions. What we're going to focus on is 1 dimension and 2 dimensions for now. So as we learn, no dimension, it's just a point. You got the line, you've got the 1 dimension, the plane that gives you, the line gives you 1 dimension. With a plane, it's a 2D, 2-dimensional. 3D is basically all the stuff that you see around you, with things that you hold, a picture, a ball, a cup, all 3D. You're in 3D. And 4D, that's another story. So let's start with our lesson. For today, we're going to deal with distance and midpoint in 1 dimension. For the next lesson, we'll deal with 2 dimension. So with 1 dimension, for the objective, we are going to find distance and midpoint in 1 dimension. So we're going to use formulas to calculate both in 1 dimension. So the formula for distance in 1 dimension is d equals the absolute value of a minus b, or the absolute value of b minus a. And I'm going to write that the absolute value, you may have seen this symbol, there's 2 vertical lines, that means absolute value. And an absolute value, whatever value is inside those 2 lines, if it's whether negative or positive, will come out positive. So when it comes to distance, so let's say we had -3 and then we had 5 for this point. We could plug in whichever. I know this one says A, so you put A wherever for -3 where A is, and then B 5. So it doesn't matter which order you put it in, as long as you have the absolute value, your answer will come out positive. And the reason why we have the absolute value, because when it comes to distance, you cannot have a negative number with distance. You can't say that, oh, I've ran negative 3.8 miles. No one says that. That makes no sense. It's positive. So that's why we need the absolute value. So we're going to do examples based on this. So we're looking for BD. So we have B, which is -7, and then we have D, which is -1. We're going to use our formula, D minus the absolute value. You can have B minus A or A minus B. I'm just going to use A minus B in this case. And I'll use the first one. So absolute value of -7 minus -1 in parentheses. Be careful with your signs. You've got 2 variables, 2 numbers that are being subtracted to each other. If there's a negative in one of them, you keep that negative. Don't just put -7 minus -1. You're just telling me that that 1 is positive, and it's not. So when you do the work, that will give you -6, and then the absolute value of -6 is 6. So be careful with your signs, because if you didn't do that, then your answer would have been 8, and that's not correct. All right. So for DG, so we got D as -1 and then G as 8. We use our formula. -1 minus 8 gives us -9, and our absolute value, so it would be 9. Let's pull this down. I'm going to veil this. I'm going to just move the others. So AF, we got A as -9, and then we have F as 3. And you're using the formula. Let's say I use B minus A. And then I use the B, so 3 minus -9. And then we find our number, which will be, since it'll be negative times the negative gives you positive, it will be 12. And then you just come out with 12. I'll change up the color. E is 0. And F is 3. Again, we're using the same formula. Doesn't matter if it's A minus B or B minus A. So be A, so that would be 0 minus 3. We get -3, and then that will come out to 3. BG, B is equal to -7, and G is equal to 8. Again, if you get the gist of this, basically, what you need to pay attention to is using the formula with the absolute value, and pay attention to the signs. So we got everything. Yep. This will be -15, and this gives us 15. Let's say for this one you use B minus A, then you had 8 minus -7. Then these two will combine, will give you a positive. It would be positive 15, the absolute value of 15, and then that will come out to 15. So if you were to do it either way, you should come up with the same answer. That one I'll move over here. So I'll just do a few more. Again, you get the gist of it. You can move on to the next section. I'm going to change that color. If you still need to see more practice, then stick along with me. So A is equal to -9 based on what was given, and then G is 8. So we plug it in, have -9, -8, -17, and then that gives me 17. And then let me move, select, move that, and move this. Alright, and I'm just going to do the last two. I'll use red for that. B is -7, and E, do I have E anywhere around here? Yeah, 0. And then for this one, I'll just, D was -1, and E is 0. Again, I'll use same formula. Don't forget the absolute value. Doesn't matter which one you put as A or B, as long as you pay attention to the signs. And then this one, I'll use B minus A. So that'd be 0 minus -1. That'll give you a 1. And let me move this down and then unveil the answers. Got 1 here, and then 7. All right. Let's go on to the next one. Now in one dimension, we have a formula to find the midpoint. So the formula is M is for midpoint, equals A plus B over 2. You may have seen the formula similar to that is when you're finding the average. So basically in a one-dimensional world, it's like finding the average. You have one number and another number, or a lot of numbers. Well, actually, in this case, since we're doing midpoint, but think of average when you have all the numbers, you add them up and divide it by how many numbers you've added up to give you the average. With midpoint, you're only working with 2 numbers. So you add those 2 and find the halfway point between those two points. So that's what midpoint is. for the one-dimensional world. All right, so we have examples based on midpoint. So this is the coordinate on the number line of j and k are -12 and 16, respectively. Find the coordinates of the midpoint j, k. So j, let's say j is -12 and k is 16. We're going to use the midpoint formula, so m equals, I'm going to put j plus k over 2. And then fill that in. So -12 plus 16 over 2. You'll have 4 over 2. So the midpoint is 2. Next one. It says same thing. You got a number line. You got j, h, and j, 14 and -7. Find the midpoint of h, j. So we use the formula again. I'm going to use the letters that they gave. H plus j over 2. Got 14 plus -7 over 2. Don't forget that negative. And then we continue. That will be 7 over 2. So you can have that as 7 over 2. Or if you want to put it as a decimal, you can have it as 3.5. So either way, this answer is the same. Okay, make sure there's nothing underneath. All right. So now we're going to apply midpoint, the formula, but now we have expressions. We're going to have to solve for x and solve for whatever segment they're asking us to find. So this is where you need to pay attention because you're looking for two things. So B is the midpoint of AC. What is the measure of x? And what is the measure of segment BC? Two things. So we have the midpoint. Again, think of midpoint. Midpoint is the halfway point. So that means this segment is congruent to this segment. I'm going to write A, segment AB is congruent to segment BC. Remember, midpoint is the halfway point. If you're the halfway point on a line, that means one segment is going to be equal to the other segment. So you can set these two equal to each other. So you have 4x minus 5 equals 11 plus 2x. Again, you solve. Solving for x. Subtract 2x on both sides. Bring down the -5 and the 11, and you add 5 on both sides. Cancel this out. Bring those two down, 2x, and then add these two, 16. Divide 2 on both sides. Your x should equal 8. That's one of them. Now they want you to find BC, this segment BC. So BC is equal to 11 plus 2x. You found x, so you plug it in, substitute, and then you simplify, and then your BC, segment BC, will equal 27. Scroll this down, move that, to unveil the answer, and there you go. So pay attention. We'll ask how the thing is labeled, what they're asking you, what they told you, what is given, what they're asking you to find, and then you solve. All right, next one. We're going to use purple for this one. So they say Q is the midpoint of PR. That means a halfway point. That means the two segments PQ and, oops, I'll put QR is congruent to PQ. So PQ is congruent to segment QR. So that means we have this whole thing. This whole thing is 14x plus 2. We only have 6x minus 3x for this segment. But since this is congruent to this, that means this is also x minus 3x. I mean, 6 minus 3x. So you got two ways to do it. You could put 3x 6 minus 3x plus 6 minus 3x equals 14x plus 2. Or you could just multiply those, multiply by 2, this part by 2, and have this equal to that. Basically, you're adding these two to give you this one. Or you could set these two equal to each other. For this one, let me see if I were to set this equal to, so I'm going to experiment. So since these are equal, I'm going to set them equal to each other, just to show you what happens. So this one will be 0, that one will be 0. So we haven't solved for x. So we're not going to do that. So I'm going to erase that. Make sure I don't erase the whole thing. Alright, so now we're going to take these two, since they're two segments and they're equal to this. So it would be 6 minus 3x times 2, just to save space, and since they're the same, and set it equal to 14x plus 2. So in this case, remember, we're using the SAP, the segment addition postulate. So we can add those two and then set it equal to this. So we're going to distribute. So then that comes out to 12 minus 6x equals 14x plus 2. And then we're going to subtract 14x on both sides. Cancel this out, bring the 12. This one is negative 20x equals 2. Subtract 12 on both sides. Negative 20x equals negative 10. And divide 20 on both sides. And then we have x equals, since the zeros cancel out, negative divided by negative gives you a positive, so we have x as a half. So we found that. Now we need to find PR, the whole thing. So now PR is equal to 14x plus 2. I'm going to change the color to green. Scroll this down. And I'm going to plug in what I found for x, which is a half plus 2. Continue. This will give me 7 plus 2. And then PR, segment PR, equals 9. Alright, and then I bring this down, unveil the answer, select. And there we go. So that's using midpoint, finding midpoint when it comes to with expressions. So it's number expression, finding midpoint in one dimension. Alright, so let's review. We learned two different formulas for one dimension. We learned the distance formula, which is d, which is for distance, equals the absolute value of a minus b, or b, absolute value of b minus a. You need that absolute value symbol with one dimension when it comes to distance, because if you give me an answer of a negative distance, you need to use common sense and say to yourself, does that make sense? Because you can't walk negative 2 miles. No one says that. So absolute value helps to eliminate that negative and turn it into a positive. Don't forget that. And then with midpoint, it's just like finding the average, but you're only focusing on 2 points. So it's whatever 2 points, whatever 2 values, you add them and you divide by 2. It's the halfway point of those 2 points. And then you could use them with numbers, or you use them with expressions. But again, you also have to go back to what we've learned, especially with segments. If they tell you something is the midpoint, you know you're the halfway point, so that means the 2 segments put together are congruent. So if they give you two expressions for the segments, you can set them equal to each other to solve for x and whatever else you need to find. And if they give you a total length of the segment and they give you a piece, then that's when you use the segment addition postulate. So everything that you learned previously, you're just using them to try to solve. Right. So this ends our lesson, and I'll see you next time. Bye.